Okay, it's filming. Solving absolute value equations. If you are good at the first lesson of just solving equations, then I think this will be an easy lesson for you as well. All right, there's only one extra piece that I need to teach you today that's an add-on from the solving equations from before. So if you're good with the first lesson, this one should not be bad for you. I will tell you this though. The one thing extra that I have to teach you today is something that students forget over and over again. So I'll be real clear where the most common mistakes are in this problem. But like I said, this should not be too bad of a lesson if you're good with the first one. All right? The only thing that I have to teach you, I like starting with a visual that I think works pretty well. And it is about a red box. All right, so here is what I'm going to start with. I'm going to do the absolute value of a red box is equal to 5. Okay, so ignore the examples here. Let's just focus on our super basic visual example here. We don't care what the red box is, but my question to you is, what does that red box equal? 5, right? If we did the absolute value of 5, it doesn't turn it negative, it would just keep it positive, so the answer would be 5. There's also another answer the red box could be, correct? Negative 5. Okay? If we did the absolute value of negative 5, that absolute value bars would turn that positive, so negative 5 could be an answer as well. So I like to write this visual out like this. Our red box can be equal to 5, that's a true statement. Our red box could also be equal to negative 5. That's a true statement based off of what we just said. All right, now what I need you to notice is there's nothing else around this absolute value. There's nothing out front multiplying, there's nothing adding or subtracting in the back. It is just the absolute value there equal to a number. So that's going to be the first thing we do when we get to these examples is we got to get rid of all the crap surrounding our absolute value. We don't care what's in the absolute value, that's just our red box. But we've got to get rid of all the crap on the other side. Okay, so once our absolute value is isolated and all by itself, then we're going to have this conversation about the red box and what it equals. Okay? All right, example 1. Do you have to copy this down, by the way? No. If you want to, because you think it helps you memorize, that's fine. You do not have to. You'll have access to these. That was weird. Okay, example 1. I'm going to do, I need to get my absolute value isolated, so I'm going to start by getting rid of 5. I'm going to do the inverse, which is negative 5. So now I've got 2 times this is equal to 12. Real quick, this is a common mistake in absolute value equations. I try to exaggerate my absolute value bars and make them longer so that this doesn't look like 13 and that doesn't look like 91. So just a tip, make sure your absolute value bars are long because a lot of students switch that to a 91. All right, one more thing I got to get rid of. This is 2 times all of this stuff. So I'm going to get rid of it by dividing, which is the inverse. And I've now got my absolute value, God bless, is equal to 6. And I'm going to pause there, God bless. I'm going to pause there because we're now at our red box situation, which is what I like to call this. My absolute value is isolated. So ignore that there is algebra in there and just visualize a red box. And I'm saying that the absolute value of whatever this red box is could be 6, because that would just keep it positive 6. But this red box could also be equal to negative 6, because if this in here is negative 6, it would just switch it to a positive 6 out here anyway. So my next step, let me scroll down. My next step looks like this. 3x plus 9, that's my red box, could be equal to 6. But my red box, 3x plus 9, could also be equal to negative 6. Where students get confused is they know there's a switching of signs, and they know they write the problem twice in most cases. Some people start changing the signs inside the red box and doing all sorts of different weird stuff. That is not the case. All right? Your red box just stays a red box, doesn't change. And just what it equals out here is what changes. Okay? Notice the absolute value bars disappeared as well. So we're taking care of the absolute value bars when we say the answer could be positive 6 or the answer could be negative 6. So that gets rid of those bars. All right, now I think I can speed up because this is pretty basic now. I'm going to do minus 9 on both sides, minus 9 on both sides. So I got 3x equals negative 3. Over here I got 3x equals negative 15. Divide both sides by 3. So here I got x equals negative 1. And here I've got x equals negative 5. And most absolute value equations have two answers. I'm going to pull up Desmos here in a minute and kind of show you why. But just know that most absolute value equations have two answers. This is pretty normal. Okay, not always, but most of the time they have two answers. All right, let's look at Desmos. All right, what I'm going to do is I'm going to plug this equation in. Someone who wrote the problem down, can you read me the equation? 2 absolute value. 3x plus 9
plus 5.
and then plus 5
Equals 17.
equals 17. Eyes up front. It does something weird when you plug the whole absolute value in. It's like two vertical lines right here. I think those might be the answers. I just don't really understand what I'm looking at in this situation. It does not give you the answer in here when you just do a normal equation. So what I'm going to do is that workaround that we've talked about before, where I'm just going to plug the left side in on one side, and I'm going to plug the right side in on the other. So I'm going to get rid of this equals 17. Okay, so we graphed that. And here, if I graph the other side, what am I going to look for on the graph? So anytime I do one half of the equation on a different line, what am I looking for after that? Where they intersect. Great job. Okay, so I'm going to just be looking for where my lines are going to intersect. There's a problem here that you need to know about. If you just plug in 17, because that's what's on the right side, Desmos does not know what we want to do with this 17 right now. It thinks we're like waiting to type in plus 5 or something. Okay, so in order to turn this into a graph that we can see, I need y equals in front. So now it'll graph it. I could put y equals in front up here also. That's not going to change anything, but I don't need it. It's only when there's a constant there that you need it, because Desmos is like, what are you trying to tell me to do? I don't know. All right, so let me scroll up. Let me zoom out. Okay, my absolute value forms a V. That's going to be a lesson that we do later. Also, all absolute values form a V. They could be upside down. And if it's just a constant, that's going to make a horizontal line. And how many intersection points are there? 2. Okay, one here at negative 5, one here at negative 1. Those are the two answers we got. Remember, we care what x equals. We're solving for x. So the x coordinate is negative 5. This x coordinate is negative 1. Those are the two answers to this problem. Is it possible to have one solution?
Yes.
What would it look like?
0.
Okay, check this out. One solution, x equals negative 3. Okay, that would be the only way we could have one solution. That's why most of the time there's two solutions. Is it possible to have no solutions? Yes. Now it's not intersecting at all. Got it? What time do we get out of this class?